AP Review Packet 1, multiple choice answers and explanations. Number 1, in one study, subjects were randomly given either 500 or 1,000 milligrams of vitamin C daily. And the number of colds they came down during the winter season was noted. In a second study, people responded to a questionnaire asking about the average number of hours they sleep per night and the number of colds they came down with during the winter season. All right, so we need to go ahead and go through A, B, C, D, and E and see which one is correct. So the first one says the first study was an experiment without a control group, while the second was an observational study. So the first one, it says I had a study where I had either given 500 or 1,000. So that was definitely, there was no control group there. It would be a control group if they were currently taking 500 and I gave the other group 1,000, but that's not what it says. I've got two groups and treatment one is 500 and treatment 2 is 1,000 and there's no control group. So that is true that there's no control group. And yes, it is an experiment because I'm giving them a treatment. The second one's an observational study, so let's read it. In the second study, people responded to a questionnaire. So I am not manipulating the variables. I'm just asking questions, seeking information, and so that definitely is an observational study. So obviously the other ones are going to be incorrect. So A is the answer for this one. Number 2, Ann Landers, who wrote daily advice column appearing in the newspapers across the country, once asked her readers, if you had to do it over again, would you have children? Of more than 10,000 readers who responded, 70% said no. I'm certain your parents would say yes. So what does that show? So let's read these through. The survey is meaningless because of the voluntary response bias. So who would have responded? People may be having trouble with their children. Maybe they were older and their children were adult children were giving them trouble, but they have a strong an emotional connection. So voluntary response bias is when you have a strong emotional connection and it's not getting the true nature of the population. So it's going to be A. Yes, that's true. But let's go ahead and go through the other ones and see why the other ones are wrong. No meaningful conclusion is possible without knowing something more about the characters of a readers. That doesn't even make any sense. You don't need to know about the characteristics of the readers in order to be able to know what the results are of the survey. The survey would have been more meaningful if she had picked a random sample of 10,000 readers who responded. So the problem with that is it's not going to be any more meaningful. That's really tempting to put, I'm sure, but it's not because it says if she had picked a random sample of 10,000 readers, but again, I'm trying to, it's going to be, again, you're going to have a response that is biased on that because it's only the people that are reading the magazine. Now, unless that was her conclusion to that population. So D is the survey would have been more meaningful if she had used a control group. There's no control groups in surveys, so that doesn't make any sense. Control groups are only for experiments in order to be able to have a cause and effect relationship. Letter E, this was a legitimate sample. Okay, and this we said no, it wasn't legitimate. Okay, number 3. To survey the opinions of bleacher fans at Wrigley Field, a surveyor plans to select every 1/100th fan entering the bleachers one afternoon. So will this result in a simple random sample? So it's one person, skip, hold on, I should write it like this. Pick one person, skip, and you're going to skip 100 of them. Pick another person, skip 100. Pick another person, and so forth and so on. Okay, and it's asking if this is a simple random sample. No, the reason this is not a simple random sample is because every person and every group of that size, so every person would have to have an equal opportunity being chosen, and they don't because these guys in here, once I've chosen where I'm starting, these 100 people that I'm skipping have no chance of being chosen. The other problem why this is not a simple random sample is every group of whatever size I have, of size, I'm saying N because it doesn't tell us how big my sample is going to be. Let's say it's size 50. I would have to say, okay, the only people that are going to be chosen are the ones that are literally going to be every 100. So it's going to be 100 every boom, boom, boom. So this person here cannot be paired with any of these people here. And so every group, it doesn't have an opportunity. Every person doesn't have an opportunity to be in the same group. So that's why it's definitely not an SRS. So, and we look here, and so that's going to be just no, because all these say yes. This is not an SRS. So this is E. Okay, number 4. A researcher planning a survey of heads of households in a particular state has a census list for each of the 23 counties in the state. What is a census? A census counts all of them, everyone. The procedure will be to obtain a random sample of 10 heads of households from each of the 23 counties. Which of the following is a true statement of the resulting sample? So what I see is that I want a random sample of 10 heads of households from each county. So I've got the counties, 1, 2, 3, all the way to 23 counties. And I am picking within the county 10 of these. So there's going to be 10 checks. 10 of these, 10 of these. So random sample of 10 of these. All right, so we're going to pick which one's true. So let's go ahead and go to 1, 2, 3, and 4 and see which ones would be true and false. This is not a proper study because children were not included. Well, that's kind of, I'm looking for heads of households, so that doesn't really make any sense. Number 2 says this is a stratified random sample. This stratified random sample is a type of, so this is true, it is a stratified random sample, but then it says it's a type of simple random sample. No, it's not a simple random sample just because I'm using a simple random sample once it's been stratified. The entire study is not a simple random sample. Okay, number 3 says this is not a simple random sample, and it's not, because all possible groups do not have a chance to be in the same group. And that's true because I picked 10 people from here. Well, then there's another, who knows, maybe 1,000 people that are not chosen. Well, they don't ever have an opportunity to be part of the group. And I could never, since I'm doing 10, 10, 10, 10, and that means from 23 counties, that means I want 230. In theory, I could, if I did a simple random sample, it would be the entire city, right? There's the entire city, and I would be picking 230. And in theory, I could get all 230 of those from county 1 in a simple random sample. That is a possibility, and I need to be able to have that possibility in order for it to be a simple random sample. In this way, I stop at 10, and all of the rest of them don't have an opportunity to be part of that study. So yes, that is true. And 4 says this study may give important information about the similarities and differences. This word may is key. It doesn't say will give, but it does have potentially. I have done a really good job of separating them into counties and doing a simple random sample of each, and that's how I know that I'm comparing them well, because I have a simple random sample of the same size of each county. So yes, so that would be A, which is 3 and 4. Number 5, a study is made to determine whether studying Latin helps students achieve higher scores on verbal section of the SAT exam. In comparing records of 200 students, half of who had taken SAT at least 1 year of Latin, it is noted that the average SAT verbal score is higher for those 100 students who have taken Latin than those who have not. Based on the study, guidance counselors begin to recommend Latin for those students. Which of the following is a true statement? Okay, so let's go ahead and look. While this study indicates a relation, it does not prove causation. All right, what do we need for causation? A cause and effect. We need a well-designed controlled experiment, so we need CRR. We need a control, we need randomization, and we need replication, and it has to be an experiment. This was not an experiment. It just was, these kids already did this. It was just an observational study. And so I cannot say this caused this. And it does seem to see that there's a relation. However, I cannot make that conclusion without putting it through an experiment. So yes, number 1 is true. Number 2, there could be well-confounding variables responding to the seeming relationship. Absolutely, there could be. You could say the reason you took Latin is because you're a better student to begin with, and then the better student is going to receive the higher score in SAT. So did the person that's a better student, is that why they took Latin? And is that why they did better on the SAT? Or is Latin the reason that they did better on the SAT? Okay, so that's why it's a confounding variable, because it affects both the treatment and the result. Number 3, self-selection here makes drawing the conclusions difficult. Yes, self-selection meaning you get to choose to take Latin, and so it's a volunteer, and so you can. It's very difficult to have a cause and effect relationship when you are able to choose which treatment you're having in. So there's no random assignment to the treatment, because this is not an experiment. So therefore, there's no treatment, and the self-selection is an issue. So obviously, it's going to be D, which is all 3. Okay, number 6, a nutritionist believes that having each player take a vitamin pill before the game enhances the performance of the football team. During the course of each season, each player takes a vitamin pill before each game, and the team achieves the winning season for the first time in several years. Is this an observational study or an experiment? All right, so let's go ahead and read through this. A says an experiment, but no reasonable conclusion about possible cause and effect. I agree, yes, it's an experiment. So let's look and see if we can have cause and effect. What do we need for cause and effect? CRR, control, replication, and randomization. So I look here and I say, look, they're taking a vitamin pill before and after a game. I don't have a control group. And this says during the course of one season, each take a pill before and after the game. And I didn't have randomization of who took it. So, and then replication, it's not done again. I mean, it is done again and again because I've got several players doing it. So that's good, but I don't have the control, so I'm not able to see if it's the vitamin or something else. So I'm going to go ahead and say A is what it is, because the other ones, these are all saying observational studies, and it's definitely an experiment because I'm giving a treatment. And this one says making cause and effect is reasonable, and it's not. Number 7, researchers were interested to know whether the internal vehicle temperatures vary by outside temperatures. To evaluate this, the temperature's rise was measured continuously over a 60-minute period in a dark sedan on 16 different clear, sunny days with outside temperatures ranging from 72 to 96 degrees. The researchers' method of analysis is best described as, all right, so if it's a census is when you survey all cars, and it's not that. And then B is a survey, which I'm not surveying anyone. It looks like I'm just observing, which is an observational study. This one says a randomized comparative experiment. A randomized comparative experiment would be if you're doing an experiment, but if it's all random and you're assigning people to randomly to different groups, and it's not that. And single blind would be if someone didn't know, or this, that, and the other, and it's not an experiment, so I just have to stop there. An observational study, there's no treatment. There's no manipulation of variables. So yes, this is going to be C. Number 8, respondents to a randomly distributed questionnaire answered this question. Do you agree that nuclear weapons should never be used because they are immoral? The study uses this questionnaire that will most likely suffer from which type of bias? All right, so it says most likely suffer. Remember, if I answer the question truthfully, bias is not introduced. However, what it's saying is a question like that is really easily, it tends to create bias because because they're immoral is your opinion, is this opinion of the surveyor. So we look at this and we say, all right, under coverage, that talks about under coverage is leaving a group out, and it doesn't seem to be probably in here. And it says it's a randomly distributed, so it's not voluntary response because they're randomly distributed. And then so C is response bias, and that is definitely what it is, because response bias, the definition is a untruthful response. And it's an untruthful response because of either the question wording, which this is the question wording, or the person asking it is causing some sort of intimidation factor to have you not feel comfortable with what your answer is. Non-response is when you don't give a response, either because you don't want to or they can't get a hold of you, like you don't want to because you're offended by the question. So if that was what it said, is that you, which this one could be that, of course, but C is much better. It's more likely this. But if I was offended by the question, I say, no, I refuse to answer that question because I'm offended by it. Or if I'm part of their study and they call me between the hours of maybe 12 and 1 every day, and I don't answer the phone because I'm working. And so it's not that I don't want to answer the question, I'm unable to. So that's what non-response is. It never can be all of the above when I'm listing all the different types of responses Well, I don't want to say never, but this one literally says which one is the most likely. Okay, so number 9, a newlywed couple is trying to choose one of the 2 new neighborhood supermarkets for their grocery shopping. They decided to randomly select 20 items, check their price at each store, then conduct a test to determine if one is significantly less expensive than the other. What test should they have? So whenever you see significant in here, then that means I'm going to be running some sort of a test. So the first thing that I'm going to do is I'm going to see what type we have. So do we have, is this means or is it proportions? Well, I am measuring the price. And so the price would mean I would probably do an average price, not a proportion. It didn't say if the price is more or less than a certain amount. So I'm going to cross out, it can't be Z because that's proportion. Goodness of fit is also proportion. So those definitely can't be it. It has to be some sort of a t-test because it's asking the price and it's finding the mean. So then I go through and I see, okay, it's comparing, it's matching. Okay, I just kind of gave it away, but it's matching 2 items. So for instance, if I bought batteries, is it just doing food? Because I guess I can buy batteries at both stores. At store 1, I'm going to have to buy batteries at store 2. And so they're going to be matched together. And so that's why I'm going to call this a matched t-test. This one would be doing a difference in my means, but this is doing where I could have 2 different lists, but the lists are not related. They're independent lists. And these lists that I'm doing are definitely not independent because if I choose batteries at store 1, I have to choose battery at store 2. It's not linear regression t-test because that's 2 variables, and I just have 1 variable. Number 10, in a certain community, 20% of cable subscribers also subscribe to the company's broadband service for their internet connection. You would like to design a simulation to estimate the probability that one of the 6 randomly selected subscribers has a broadband service. Using digits 0 through 9, which of the following assignments would be appropriate to model the situation? Okay, so I'm using digits 0 through 9, and I'm using 20%. So that means 2 of the digits are going to represent cable, and then the other 8 digits are not. So that's kind of what I'm going to be looking for. So look at A, it says assign even digits. Well, even digits is 5. And so I know, boom, that's not it. I couldn't read the rest of it, but odd digits to the other one. So that's 5 and 5, not it. B is assign 0 and 1 to broadband and the other ones to cable. That's definitely it because it's 2 and 8. I'm just going to scan through the rest of them and make sure I didn't read B wrong. So I say, well, that's 3. And so that's not it. This one is 6 of them and 4, so not that. This is 3, and then this is just weird. This is 3 and 1, and I don't know, that's just strange. So it's B, because it's the only one that has the 20-80 split in the correct manner. Number 11, number of t-shirt sales are distributed in this chart. If each t-shirt sells for $10, but the store purchases it for $4, what's your monthly expected profit? Well, my profit on each shirt is $6 per shirt because $10 minus $4. And this is my probability distribution of how many shirts I buy. So if you guys remember, it's this times this plus this times this plus this times this and so forth and so on. And you can put these in your calculator, or you can go ahead and put it on your spreadsheet, which I'll show you how to do here. All right, I went ahead and did it in my spreadsheet, and I went ahead and ran the test, but I'll run it for you again. But I did t-shirts, and that was my first column, and my other one was a frequency column. And the way I came up with my information, which is the mean is $3.78, the way I came up with that is I went menu, 1 variable statistics, 1 list, and my X list I called t-shirt, and my frequency list I called freak X, and I hit OK. I'm not going to hit OK since I already have it. And what you're looking for is X bar, which is $3.78. So what does that mean? Well, that means not $3.78, I've been saying that, but 3.78 t-shirts on average per month. So $6 per shirt times 378 is going to get us $22.68. Number 12, a young woman works 2 jobs and receives tips for both. So she has the mean of when she's a hairdresser is going to be $65. Her standard deviation of her hairdresser is $5.75. Her distribution, her mean when she is a waitress is going to be $154. And her standard deviation when she's a waitress is going to be $8.02. All right, so for means, it's asking the mean and standard deviation of her combined jobs. Because they're independent, I know I can add these together just like this. And I add them and I get $219. I cannot add your standard deviations. You have to, but you never can add standard deviations, okay? Can't do that. But you can add the variances. So we're going to do this. We're going to do $5.75 squared plus $8.02 squared. That's my variance, the standard deviation squared. But I don't want my variance, I want my standard deviation. So then I'm going to find the square root of that sum, and that is going to get me my answer, which is D, which is $9.87 and $200.19. A cause and effect relationship between two variables can best be determined from which of the following? So let's kind of read through and see. A survey, okay, no. A survey, no. I didn't even have to read it. You cannot have a cause and effect unless it's an experiment. When two variables have a correlation coefficient near 1 and -1, that says nothing about an experiment, so I can't, it doesn't matter. That the correlation coefficient, that just means that everything that I'm predicting is on my line. That's what that means, but it's not an experiment, so I cannot just say that. So an observational, no. So obviously it has to be E. It wasn't very hard because that's the only one that's an experiment, but look, a controlled experiment, where the observational units were assigned randomly to treatments. Because that's control, randomization, replication. Got it? All right. 14, in a game of chance, 3 fair coins are tossed simultaneously. If all 3 coins show heads, then the player wins $15. So let's make a probability chart. So I have heads, heads, heads. And to get heads, 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 that's 1/2 times 1/2 times 1/2. All right, and that is, so this is my probability. These are my potential outcomes. And so that's 1/8. And what do I get? I get $15. All right, or tails, tails, tails. Well, tails, tails, tails has the same probability of 1/8 because it's 1/2 times 1/2 times 1/2, but I only win $10. If it costs $5 to play, well, then what's the expected net gain? Well, what about everything else? So all other combinations is going to be 6/8, since I have 1/8 plus 1/8, and then 6/8 is everything else, and I don't win any money there. Well, it says it costs $5 to play, and it's asking for my net gain, so I don't really win $15, I really win $10. I don't really win $10, I really win $5. I don't really have a net earn of 0, I have a net earn of -5. So this is going to be just like what we did up there, is 1/8 times 10 plus 1/8 times 5 plus 6/8 times -5. And you're welcome to put it in the table just like I did and run it in a one variable statistic and look for that mean. Or this one's pretty simple. There's only 3 of them. Just throwing it in your calculator just by hand is probably just as quick. And so you're going to get that, and you're going to end up with a -$3.75, which means losing $3.75. So not a good game to play if you're trying to earn money. Not profitable. Which of the following is true about an experimental design? Replication is a key component of experimental design. Thus, an experiment needs to be conducted on repeated samples before generalizing results. Okay, so we look at that and we're like, all right, well, that may be something that I kind of one of those things, like I do want replication. However, I want to see what my other answers say to see if there's something that has a little better answer. So I'll come back to that one. Control is a key component of experimental design. Thus, control group receives a placebo and is a requirement for experimentation. Now, this is saying require for experimentation. So, no, control is not a requirement for, and that's why it says requirement, is not a requirement for experimentation. Sometimes you can't have a control group. We do prefer a control group, but you don't have to have a control group to have an experiment. Randomization is a key component in experimental design. Randomization is used to reduce bias. Absolutely 100% true. So I'm leaning definitely towards this one because it seems like that's the right answer. D says blocking eliminates. When you say eliminates, you don't even have to finish reading. It does not eliminate. Placebo effect is a concern for all experiments. No. What the placebo effect is when you think you're taking the pill, so you think you're getting better just because you think you're taking the treatment, where you used to have a headache, you ask your mom for an aspirin and she gives you a sugar pill instead, and you say, oh, the aspirin made my headache go away, it's all gone. So that's a placebo effect. Going back to here, replication is a key component in experimental design. Thus, an experiment needs to be conducted on repeated samples before generating results. You can, the replication, when it says the experiment has to be conducted, replication is not talking about the experiment being done again. It's how many people you're doing it on. So that's the problem with that one. When I read it again, I thought, okay, there must be something I'm missing, and that's what it is. Okay, number 16. An experimenter believes that 2 new exercise programs are more effective than any current exercise routines. So we have a new and an old one, and wishes to compare the effectiveness of these 2 new exercise programs on physical fitness. The experimenter is trying to determine whether or not a control group, which follows neither of these new problems but continues with current exercise routines, would be beneficial. Which of the following can be said in the addition to the control group? A control group would, eliminate, never eliminate. So I didn't even have to read those when I said eliminate. Okay, yeah, on the AP test, you'll read the whole thing. But eliminate is automatically tells me that's not going to be true because it cannot eliminate, it just reduces. Letter C, a control group would allow experimenter to determine which of the 2 exercise programs in physical fitness. Well, it's a little bit more than that, but this is because the control group is not what allows it to. Let's go in part D, and I think you'll see the difference. A control group would allow the experiment to determine if either of the exercise programs is more effective than the current one. This one, it says which one, and this says either. So you see, this one, as you read it, like, oh, it sounds good, but when you see further down, you're like, wait a minute, that's the difference, is it doesn't tell you which one is better, but it does tell you if either is more effective. The most, because we don't know. So, and then that one's wrong. Okay, so this is D. "17, a drug company wishes to test a new drug. A researcher assembles a group of volunteers, randomly assigns them to 2 groups, one to take the drug and one to take the placebo. In addition, the company wants to experiment to do a double blind. What is the meaning of double blind in this situation? The volunteers in both groups are blindfolded when they take the drug or placebo. Well, that would be single blind, and so it needs to be double blind, so that wouldn't be it. The volunteers in both groups do not know whether they are taking the drug or placebo. That's correct, but that's only single blind. That doesn't describe double blind. Neither of the volunteers nor the drug company executives know which of the volunteers are taking the drug and which are taking the placebo. All right, that sounds good, but remember, it's not the drug company executives that are doing the experiment, it's the evaluator. You'll see the difference in C or D. So it's D, but C sounded good because it's like, that's definitely double blind if the drug company execs were the evaluators, but they're not. The evaluator is it gives you a little bit more information. As long as the subject's randomly assigned to 2 groups, there's no need. Okay, and that's just ridiculous. Double blind has nothing to do with random assignment. Number 18, since many of the individuals walk around their homes in socks, the manufacturer has a new material that's believed to be more resistant than cotton. The manufacturer wishes to test it over a period of time. Given the group of volunteers, which of the following designs is the best test? All right, so it's asking for the best test. It's not saying some of these are worse, some are going to be worse than others and some are going to be appropriate, but there's other designs that are better. Have the volunteers wear socks made from the new material for a month and check the wear on the socks at the end of the month. This is a problem because there's no comparison to the old material. Allow half of the volunteers. When you say allow half of the volunteers, that means there's no random assignment. So already I'm not liking this one. Wear cotton socks while the other half wear the new socks. Yeah, and so again, there's no random assignment, so that one's out. And you have to think if they're 2 different groups, group 1 and group 2, group 1 might be more active than group 2, and then that would cause the socks to have a different wear just because of the activity level would be a confounding variable. Letter C, randomly assign half of the volunteers to wear cotton socks. I like the random assignment. While the other half of the socks are made for the new material, this is a much better one, but the same problem here is that if you have a more active group than a non-active group, then that's why that there's probably one that's better. But so far, C is the best one, but let's keep going, and I'm guessing there's going to be a better one. Randomly assign half of the groups to wear the cotton socks, and while the other half are made of the new material, and at the end of 2 weeks, they're switching. Oh, so that's good. So now everybody wears it. But the only problem with this is what if I know during COVID time, my socks got a lot of action because I was around the house a lot. They got a lot more, right? And so they kind of got an increase. So then if I was in month one before COVID, my socks are typically protected by my shoes. Because I'm not around the house, I'm having to work and go other places. So anyway, the problem with here is that I like how they're random. I like how each group gets both pairs of socks. But the thing I don't like is that I think this one's going to be better because this one has, on your left foot and your right foot. And so wherever your left foot goes, your right foot goes. So this one's a little bit better because it gives you each one are going at the exact time, and they've been randomly assigned as far as which one gets the new one and which one gets the old one, and then you'll compare at the end of the month, and so it will be the best design. But they actually got better and better as they went down. So don't pick one without reading everything on that, especially when it asks for the best. Got to read all that. Okay, 19, a psychologist from Austin, Texas, interested in sleep effect and the ability to learn randomly, selects the high school students from the area's local high schools. Half of the students are randomly selected to sleep between 7 and 8 hours, while the remaining half sleep as they normally would. At the end of the study, those students who got between 7 and 8 hours of sleep scored significantly higher on the test over the curriculum studied in their school. From this, psychologists can conclude Austin high school students getting between 7 and 8 hours of sleep score higher over the test. All right, so what did I do? The only way I can conclude is see where I got my population from. My population is randomly from Austin high school students. So yes, I agree with part A that I can make my conclusion to Austin high school students. And so that's all it can do. It can't say all high school students. It can't say all Texas high school students, but definitely can. And that's the problem here. I can't do United States. C says Austin students who sleep 7 and 8 hours get better grades. This is a little bit too general. This one here, higher test scores over the curriculum. So this one's a little better because if you look through the question and read it, you'll see where it says over the curriculum at their school. So that matches A better in the stem of the question. So that's a problem there. High school students getting between 7 and 8 hours of sleep per night score higher tests. Again, what high school students? What's my population? My population was Austin high school students. Since a placebo was not in the study, no significant conclusions. No, you don't have to have a placebo to be able to have a significant conclusion. So that one was A for 19. Okay, and finally, number 20. Which of the following hypothesis tests automatically include blocking as part of the design? All right, so when you look at it, you say, okay, 2 sample t-test, 2 proportion, match pair. Oh, whoa, wait a minute. Match pair, you have to put one versus the other. It's remember the hairdresser one when I have block 1, block 2, block 3? That one was literally ready to set up for a match pair test because it puts a pair of person. Remember we had volunteer number maybe 3 and number 4. It put a pair together and that automatically set up. The rest of them are not automatically set up in block design. Okay, and that's B. All right, I hope that helped you. And if you have any other questions, let me know.